And with that, I'm going to hand it over to Roger Wiens, who is the PI of the ChemCam.
Thank you, Mike. So to complement this imaging, a rover like Curiosity also needs to get compositional information from a distance. And so ChemCam fulfills that role. It will help guide the rover to the most interesting samples in which the analytical and contact and in situ instruments can spend more time and be most efficient by doing this with the most interesting samples that we find at a distance. So ChemCam consists of two instruments that share the same telescope up on the mast. One is, and let's go ahead and roll the first video clip. One is a laser-induced breakdown spectrometer. We call it LIBS, L-I-B-S. And the other is a remote microimager, which provides context close-up images of the spots that we shoot with the laser. So LIBS has many advantages. It can remove the dust from a distance by multiple laser shots, and it can also analyze that dust, but it can remove it and then analyze the rock that's underneath without being hindered by the surface. And so it's like an arm that can reach out up to 25 feet away, brush something off, analyze it, actually look at the weathering surfaces and the interior of the rock at the same time. There are two main. Actually, before I go on, I'm gonna mention that the instrument is a multinational collaboration between France and the U.S. And so half of the instrument was built in France and was contributed by the French Space Agency, and the other half was built in the U.S. So to represent the French part of it is in the audience is Dr. Olivier Ganot, and you can address questions to him as well. So there are two main parts to the ChemCam instrument corresponding to the French and U.S. So we're going to run the next clip here and show you those first, and then we'll give a little demonstration. So here is the body unit. This was built in Los Alamos in the U.S., and you see a command and control unit at the bottom, and then you see three spectrometers which actually do the sensing for the ChemCam LIBS. This is the mast unit shown here, and this was contributed by France, and it consists of the laser, the electronics for that laser, and a telescope with a 4.5 inch diameter, and a camera that takes RMI images. And what we're going to do here is we're going to show you a little demonstration of what LIBS looks like in real life, not in the animations. So we're going to shoot at a pyrite target. It's a mineral target that's about 8 feet away, and you're going to see the LIBS flashes. And you'll note that the laser beam itself is actually invisible, but for the sci-fi buffs we have to show it in the pictures. But there you see a still image of the LIBS plasma. So the laser basically takes the energy of 1 million light bulbs and it focuses it onto a spot the size of a pinhead. And what that does is it ablates material off of that sample in an extremely hot state of thousands of degrees, and when it comes off it's shining brighter than a flame. And so what we do is we look at that light and we sense the composition of the samples that way. So the next slide will actually show how that works. So LIBS really consists of two components, or two aspects. The first is the laser, and that is the interrogating part. So that sends the energy in to the sample and produces the plasma. And then the second part is the spectrographs, which we have to sense the light and tell us the composition. And at the bottom of this image you'll see different color plasmas, and that's actually how we see them with our eyes. And so when we were running calibrations we could say, oh, this sample looks blue, or that one looks a little different color. And the other thing that you notice from this is that these are relatively large plasmas, and that's the case on Mars. In fact, with the Mars atmosphere you get a bigger and brighter plasma than you do in these pictures that I just showed in the video on Earth. And so I hope my colleague Mike will get us some good pictures of our plasmas there. But now I'll show you how ChemCam gives the sensing part of that with the next image. So this is the spectral range from one of our three spectrometers that sits in the body of the rover. And by the way, the light comes down from that telescope down along the mast and into the body of the rover along a 20-foot long optical fiber. And then it gets into the body and it's sensed like this. And so the spectrometers actually spread out the light along the wavelengths, and then you see these emission lines. And the emission lines represent different elements. and they're labeled there for this spectral range. And you can see that some of the elements have many emission lines, some have only a few, but we spec our instrument to cover essentially the whole periodic table. And so we go from the UV through the visible range and a little bit into the IR range as well. And that's done, or I should mention, some of these elements include elements like hydrogen, nitrogen, carbon, and oxygen, which are, of course, all very interesting, not only to follow the water on Mars, but also to look for materials that would be of interest for the exobiology. So now I'll turn our attention to the imaging, and we do provide context images for the analysis spots. These are very small analysis spots, and so we want to see what we're shooting at. So just to demonstrate that, we took a US $1 bill, and we put it at a distance of 10 feet away, and we shot it there. But we'll show you the image, and the image in the next slide actually shows just this part of the dollar bill. And from 10 feet away, say those of you in the front row, you wouldn't be able to see a lot of detail. But this image that you can see up close, if it's really actually expanded, you would be able to see a whole lot of detail on that dollar bill. And so we provide, in the context of these LIBS shots, we provide an image that has almost the resolution of Mike's, but it's monochromatic, and we're really doing that just to show us what are the samples that we're really shooting at. So in summary, a ChemCam really just provides a guide for the other instruments on the rover to help optimize the other instruments, and it also provides science in its own right as well. But to talk about those analytical instruments, I'm going to turn it over to Dave Blake for ChemIn.
Thanks, Roger. Okay, well, once the mast instruments and the